So today we learned how to do factoring, and we practiced a lot of factoring. And today we're going to talk about our special factoring. Now this stuff is on your formula chart. It's at the very top. I don't like these patterns, and the reason I don't like them is because they use A and B, but they're not the A and B from our standard form. So it's like basically like all of a sudden we're talking about A and B. So this is the A and B that you're used to seeing, but that's not the same A and B's as they have here. I need you to know that they're at the top of your formula chart, but I'm going to show you how to identify them. I'm going to use the letters A, B, and C. All right, so that we're not using these weird letters. So it's on your formula chart, but I want you to know how to do it more than I want you to know how to read it off the formula chart. Okay? So the special that we have here is called the difference of two squares. Okay? And what the difference of two squares, the reason we call it the difference of two squares is because we have something that looks like this, and this is a perfect square, and that is a perfect square, and they're subtracted. Mathematically, subtraction, the answer to a subtraction problem is a difference. So it's a difference of two squares, okay? When we see a difference of two squares, it's always going to have a subtraction sign, and it's always going to have, and there's never going to be a B, okay? And when we saw those problems today, the reason for that was because B was 0. And the only way that I can get a number to add up to, the only way I can get something where B is 0 is to add a 0 pair. So that means I'm going to have, like in this case, a +3 and a -3, or in this case, a +6 and a -6, okay? So what those look like when I see that, what's going to end up happening is, so the way that here, let me show you the way that we're just going to, well, that's fine, you can leave that written down, but the way they write it is a squared minus b squared equals a minus b, a plus b. So when they say a, they're referring to this entire term. So see here how this is 36? They're saying that a squared, so a is one of these. So a would be the square root of 36 and the square root of p, so 6p. All right? So whenever you see a pattern where you have perfect square minus perfect square, here's what you're going to do. I'm sorry, I'm going to erase again. What you're going to do is you're going to take the square root of the first one and the square root of the second one, make that the first part of each term, and then you're going to put a plus or a minus sign. So let's pretend I have this. I have 25x squared minus 9. Okay? When I look at this, I see I have 25, which is a perfect square. That's 5 times 5. X squared is x times x, minus 9, which is 3 times 3. So I see perfect square minus perfect square. So what I'm going to do is I'm going to take the square root of 25, which is 5, the square root of x squared, which is x. I'm going to take the square root of 9. I'm sorry, I'm going to put that 5x in both of them. I'm going to take the square root of 9, which is 3, put that at the back end, put a plus in one and a minus in the other. Okay? And what am I going to write for work? Dots. That's my work. So whenever I see this pattern, if you identify this pattern, okay, then you don't have to do all this work. Your work is writing dots, telling you that I have found the difference of two squares. Let's try another one. Okay, so let's say we have 25x squared minus 100. Okay, now I could just take the square root, but the first thing that we always do is look for a greatest common factor. Do I have a greatest common factor here? Well, yes, I do. The greatest common factor here is 25, because I can divide this by 25 and that by 25. When I divide them by 25, I get x squared minus 4. Okay? Well, do I still have a difference of two squares? Well, let's look. X squared is x times x. 4 is 2 times 2. Yes, I still have a difference of two squares. So I put the square root of x squared, which is x in the first one, the square root of 4, which is 2 at the end. I put a plus and a minus. And then my work is dots for difference of two squares. Okay, so that's the first special. The second special is a little bit more complicated, so let's take a look at this. I don't think we finished these problems in class, but this is what it would look like if I worked them out. So if you look at this one, I have x squared plus 6x plus 9. And when I actually do all the work, I get x plus 3x plus 3. Another way that I can write that is x plus 3 squared, right? Because any number times itself is a perfect square, all right? Same thing over here. 4r squared minus 20r plus 25. Now you might think this has a greatest common factor. These two have a factor in common 4, but you can't divide this one by 4. These two have a factor in common 5, but you can't divide this one by 5. So you can divide these by a lot of things, not by the same thing, okay? And when I work it out and I did all the work, I got 2r minus 5, 2r minus 5. And I can write that as 2r minus 5 squared, all right? So we call these perfect square trinomials, or PST. All right. So when we look at this, there is a pattern. First of all, the first and last term in the trinomial have to be perfect squares. So the quadratic and the constant terms must be perfect squares. Okay? The other thing that has to be true is this. B over 2 squared has to equal A times C. Okay? I know, right? And again, this formula is on here. Yeah. So basically, what you have to do is you have to look at this, square this. It has to equal half of this. It has to equal those two multiplied together. So let's just take a look at what that looks like. First of all, let's look at x squared plus 6x plus 9. Okay, that's the one that we did in class. Okay, well, we may have done in class. We may not have. I don't know. Okay, so for this one, I need to know A, B, and C. A is 1, B is 6, C is 9. Okay, are these perfect squares? Well, this is 1 times 1 times x times x. This is 3 times 3. Yep, those are perfect squares. Well, I guess you don't need the 1 times 1. Okay, it's x times x and 3 times 3. So those are perfect squares. The next thing that has to be true is b over 2 squared has to equal ac. So I'm going to just write myself an expression. Okay, 6 over 2 squared has to equal 1 times 9. Well, I have a calculator. I'm just going to use my calculator. Yep, my battery's low. It's very angry. Okay, so 6 divided by 2 squared is 9. 1 times 9 is 9. That's true, so this is a perfect square trinomial. So then here's what you do. You take the square root of the first number, you make 2 parentheses. The square root of the first number in the first place. The square root of the last number in the last one, whatever the coefficient of b is, that's what sign they have. So that also equals x plus 3 squared. And your work is dot. Your work is PST for perfect square trinomial. Okay. Let's try another one. Okay. Let's try. Let's try the other one. 4r squared minus 20r plus 25. So 4r squared minus 20r plus 25. Okay. So a is 4. B is negative 20, C is 25. Okay, so first I look and I see if these are perfect squares. This is 2 times 2 times r times r. This is 5 times 5. Those are perfect squares. So now, B, so 20 over 2, well, negative 20 over 2 squared, should equal 4 times 25. Okay, so negative 20 divided by 2 is negative 10, squared is 100. Okay, 4 times 25 is 100. That is true. So I could just make one set of parentheses and put squared next to it, or I could put 2 sets of parentheses. I take the square root of the first one, which is 2r, the square root of the last one, which is 5. Since this is negative, they're both minus. So that's 2r minus 5 squared. All right? We're going to practice this some more tomorrow. That's, what we're going to practice tomorrow. So if you have any questions, please come with questions tomorrow. And I hope this was easy. Have a good day. See you tomorrow.